and welcome to IAS Masterclass. This is Mr. Jose. In the fourth part of our climatology series, let us deal with humidity, precipitation, and clouds. Why is climatology so important? Because it's the most dynamic subject in physical geography. 3 to 5 questions are asked in mains, General Studies Paper 1, and 2 to 4 questions in prelims. It's very easy to understand. Once you get the logic, this subject is very easy to cover, and it's valuable for future bureaucrats. The syllabus for general studies is atmosphere, temperature and pressure changes in troposphere, temperature inversion, pressure belts, planetary winds and local winds, jet streams, humidity, cyclones, climate classification, and climate change. Let us deal with humidity today. Humidity is expressed in various ways. One is absolute humidity, the other is specific. There is one called mixing ratio, and the most important, which we use in daily life by meteorologists, is relative humidity. So what is humidity per se? Humidity per se is the amount of water vapor present in air. Absolute humidity. Absolute humidity is the mass of water vapor in unit volume of air. That is, grams of water vapor is expressed as grams of water vapor per cubic meter of air. Specific humidity, while it is two masses here, mass of water vapor per total mass of air. This total mass includes both dry air as well as that wet air, as well as that water vapor. So it's a mass of water vapor by mass of dry air plus mass of water vapor. And mixing ratio is nothing but mass of water vapor per total mass of dry air. So there's a difference between specific humidity and mixing ratio. We are more interested in relative humidity. Let's say we say there is 50% humidity. What does that mean? It means that amount of water vapor present in air is 50% of the amount it is needed to saturate that air at that temperature. What do you mean by saturation? That is the maximum capacity of water vapor it can hold at a certain temperature. So what is relative humidity? Relative humidity is the amount of water vapor present in air. It is expressed as a percentage of the amount needed for that air parcel to get saturated at a certain temperature. As we see in this diagram, moisture is 100%, relative humidity is 100% here. Moisture is 50%. Relative humidity is 100% here. Moisture is 5%. It depends on the amount of water vapor that air can hold at a certain temperature. Now let's come to the various types of precipitation. Precipitation, rainfall and snowfall are very familiar to you. Let's look at what sleet is. Sleet is nothing but rain and snow combined, right? Haze. Haze is water vapor droplets and smoke and all that. It actually mixes with the air and it gives us a hazy atmosphere, like not very clear skies and all that. Hazy is like foggy, we call it interchangeably, but haze is basically a mix of water vapor plus the particles available in air, hygronomic particles available in air. Hailstorm. Hailstorm is what? Hailstorm is those thick snow-like pebbles which fall down, right? Now, how is hailstorm formed? Does it form in all regions? Not really. Hailstorm needs a particular condition, that is, the temperatures have to be very high and there has to be a little bit of moisture there. Now what happens with that? Moisture should not be, the relative humidity should be low, the moisture should not be high. What happens is, because of this high temperature, the convection currents will be very strong. That means the air parcel which rises and which is about to condense to form clouds and all that will get lifted again and again as it moves into the upper atmosphere. And where it reaches a point where it starts to condense, it cannot rise further. And what happens is, in those intermediate layers, we'll have a partly condensed, air, water vapor, partly condensed water vapor in air in all those levels below that higher level. At that higher level, the dew point is mostly less than zero. Dew point is that point when the water vapor condenses in air. So that is less than zero. That means it will fall as snow. And as it falls down, it will take up all the bottom layer, partially condensed water vapor. That means it's almost like an onion which is peeled. outwards, right? And when it falls down, so it will take up all this partially condensed water vapor and it will become very thick. So that is why we call it snow pebbles and all that. So that's hailstorm. Okay, now let's look at clouds. Clouds, of course, is the first step before precipitation happens, right? People get confused with the names of clouds and whether it will cause rainfall or not. So let us make it that easy now. See, clouds can occur right from 600 meters right till around 11.5 kilometers in altitude. Now, according to the altitude, clouds are classified into high altitude clouds, that is about 6 to 11 kilometers, we call it cirrus. Middle altitude clouds, that is from 2 to 6 kilometer, we call it alto, and Maruti alto, right? And now, and below that, we call it by their normal names in terms of the shape of those clouds. So what are those shapes that clouds are found in? Either they are found like in sheets, in layer form, or they are found like globular, like cotton and all that, right? So the sheet-like cloud form is called stratus, and the globular ones are called cumulus. So that means cirrostratus should be a high altitude stratus cloud. Altocumulus would be a middle latitude globular cumulus cloud. So that is how this classification goes. Let's look at those pictures of these clouds. The normal cirrus cloud, high altitude cloud, would be somewhere here. Yes. This indicates that, okay, a storm is slowly coming. Now this one actually forms a halo, right? So when there is a halo formed and all that, and so you see the halo here. Okay, and this clouds, this indicates that a storm is coming in around 24 hours. So we have to brace up for a storm. This is cirrostratus mostly indicates fair normal weather, but in tropical regions we have a problem. Cirrocumulus, of course, it means fair weather, so there's no risk of rain. Yeah. So three types. So cirrus basically cirrostratus and cirrocumulus. Coming to alto, again altocumulus and altostratus, both are kind of associated with not so fair weather. So that is altocumulus, maybe it will take some more time to rain. Altostratus, it is like sheet-like. So in temperate regions and polar regions, when you have altostratus clouds, it doesn't mean that it will rain or snow. Mostly it snows then, but the chances are dim. But when you come to tropical regions, when you find such a cloud, altostratus, it is sure to rain. So altostratus. Nimbus clouds means rain-bearing clouds. So that means the shape of that clouds, whether it is stratus or cumulus, whether it is rain-bearing, then we call it nimbus. So if it can be nimbostratus, cumulonimbus. Cumulonimbus are those big thunderstorm clouds. Stratocumulus clouds, that is kind of the first indication that something is coming. For instance, before the monsoon sets in, we'll see such stratocumulus clouds in the atmosphere. Okay, these are the major types of clouds that you can see. Now let's come to types of rainfall. In fact, there are 4 types of rainfall. The simple way of rainfall is convectional, where you find that, okay, from water bodies there is evaporation, this evaporated air, this water vapor rises to a certain height and it forms moisture and then slowly start to condense, and as it reaches the dew point, it completely condenses and precipitates as rain. This type of rainfall is particularly seen in tropical regions, in equatorial regions, where you have almost on a daily basis you have convectional rainfall. Orographic means oro is mountain, so mountain induced rainfall. That means just like the Western Ghats, the Himalayas and southern slopes of the Himalayas and the Western Ghats, we have this mountain induced rainfall. So the prevailing wind which carries moisture, it actually sheds its moisture because it is forced to rise because of this mountain. And the moment it is forced to rise, it will start to make clouds and it will precipitate. And the air which is devoid of moisture, because moisture has been shed in that windward side, goes towards other side, which will form a rain shadow region. A typical example would be Kerala and Tamil Nadu. The Kerala receives a lot of rain courtesy Western Ghats because they trap the monsoon winds. The rain shadow region is where Tamil Nadu is. That is why southwest monsoon doesn't actually help in terms of rainfall for Tamil Nadu. Okay. The other two types of rainfall, frontal and cyclonic, are kind of related. Tropical cyclones are a little different from frontal. They have nothing to do with fronts. That is basically high sea temperatures. We'll come to in detail about tropical cyclones, but extratropical cyclones and temperate cyclones are more associated with fronts. Fronts, we have seen in the last video, are those boundaries which are actually created between two air masses, contrasting, converging air masses. So these are the types of rainfall. The next session will deal with tropical cyclones. Thank you.